Now, Fisher said he wanted to observe the same molecule. Now, but he said that I don't want to observe the molecule from this side. How he said, he rotated this molecule like this, right? First he rotated. So it was the actual position. He rotated the molecule like this and then tilted it like this, right? He said that none of the bonded groups would be in the same plane as the carbon. Earlier, two of them were in the same plane when calculated it. But now, Fisher is saying none of the bonded groups will be in the same plane as the carbon. So carbon is the only thing which is in the plane. So let's do it. This is the carbon, the black carbon. Okay. So if this is the carbon, then two of the groups will be going out of the plane away from the observer. So this right now, this green ball and white ball over here are again out of the plane. None of them are in the same plane as the carbon. Carbon is the only thing which is in the plane. So these two are going out of the plane away from the observer, and they will be represented on the vertical line around the carbon. On the 2D surface, they will be represented on the vertical lines. So over here, I can represent this green ball. And then over here, I can represent this white ball. Just white ball. Then the two groups which are again coming out of the plane, but towards the observer, the two groups which go out of the plane but towards the observer, they need to be represented on the horizontal lines. So they will be represented on the horizontal lines with blue over here and the yellow group here. So now you can see that this is the position from where Fisher was observing a molecule, right? Where only carbon is in the plane, all its bonded groups are out of the plane. The two groups which come out of the plane towards the observer are represented on these horizontal lines, while the two groups which are going out of the plane but away from the observer, then these are represented on the vertical line.